Hello, this is Brian Wood recording a brief walkthrough and demo of some projects that I wrote for the Adafruit Circuit Playground Express. And these projects were for a high school event at Grand Canyon University. Hundreds of students came for being able to experiment on these little boards at GCU. And I had the privilege to develop some projects to help be a part of the instruction. But aside that, let's get into the code to begin with. And then we can actually start showing some of the demos at the end of the video. So this code to begin is not my original code, but it is, it was originally written in Python. And I have appropriated it to be used in Arduino because I needed to write an example Arduino script or sketch for the project itself. And so here is my Arduino sketch. And what this simply does is allow us to press a button on one of the side of the board, and all the LEDs on that side of the board, be it left or right, will turn on depending on which button you press. It'll be red or blue. And I believe it was actually from Core Function, or I can't remember the name of the company where I got the Python code, but I've turned it into C++ or C++-like with the Arduino sketch. And just to make a brief walkthrough, we can see that we have, with the initiation of the hardware, we set the brightness of the lights to full, and we are checking to see if the left button is pressed or the right button is pressed, and we will set the color, and this actually iterates through several different LEDs. It's 5 on either side, as we can see the index of 5 there, or the condition of 5. And this set pixel color actually sets the color of red. It's in RGB values, so 255 in the red category, in 0 in blue and green. And then this show function actually writes all those changes to the board itself. And it continually does that. And the same for the right button, but blue, as we can see here. And then else it will clear the pixels, turning them off, and then it will show that. And so on. All right, to the next couple projects. So we have, let's begin with the cycle colored lights. It's fairly simple. So this project actually makes the LEDs blink in a circle a few times, but it's all different colors. So it'll start, as we can see in my LED colors array here, it'll blink red, then yellow, and all the way down to purple, or violet, I guess my comment says. And we can actually change the number of cycles like that here if we wanted to see the rainbow, a few times. And this is just a simple count of the LEDs, so it makes it easier to increment here later in the Python code. And all this is doing, that's actually 2 embedded for loops. And the first loop is to repeat the sequence blank times, n times, which is based on the number of cycles, which we define up here. And then this second part actually iterates through the colors array. So color we could treat as the index, and it will go through red, yellow, all the way down to violet for each iteration of this loop. And then this final loop actually iterates through the LEDs. So it will fill the LEDs off, or it turns them all off, excluding this one here. It will turn them all off, and then it will color, or I'll set the fill to 0, so it doesn't necessarily turn them all off, but it will then recolor the index. So let's say it's 0, then that LED 0, which is down here towards the green light, will turn on, will be whatever color that we set, and then we show that, we sleep for 100 milliseconds, and then we resume the iteration. And then we just have an entry point, a perpetual while loop down here. We check for if CPX button B, which is this button on the left-hand side, if we press that, that will initiate the cycle, and it calls that function to take care of that, and then we turn them all off, all the LEDs off at the end of this cycle, once the return has happened from that function. All right, moving on, I will just cover a basic accelerometer, then I'll cover an improved accelerometer. So this first accelerometer, similarly to the other Python code, we set a brightness, we set the fill to 0, we show that, and then what we do is we actually get the last values, which not last in the first instance, we actually are just reading from the accelerometer, but we assign that data, x, y, and z, the data of the axes on the accelerometer, to these three variables, and then we set a threshold of 2, so if there is a change in the axis that is 2, or it's greater than 2, then an LED will blink. So for instance, if we are taking this board and we lift it up straight up on the y-axis up to a total of 2 units, then we will notice an LED turn on, and similarly for x and y. And for x, we will see an LED turn red. For y, we will see it turn blue. And for z, we will see it turn green. And at the end of this, we actually assign the latest red values from the accelerometer to the last variables, last x, last y, and last z. And then we use those for our comparisons later in the next iteration. So we will subtract the current reading. We'll subtract the last reading from the current reading, and if that is greater than the threshold, then we will see an LED. And that's it for the basic accelerometer. There will be only 3 LEDs that are involved down here, 0, 1, and 2. And for accelerometer improved, this actually takes into account a positive versus negative change in the axes. So, for instance, if we move the board left versus right, we will notice 2 different LEDs turn on. For the x coordinates, or x-axis, excuse me, it will turn this LED on if we were to move it this way, and in the reverse, it will turn that LED on if we move it to the right. And it does that for all the y's, all the axes, y and z. And it sets the same colors, and it's literally the same process, using the same last variables. We fetch the same cp.acceleration data, and then the only difference is that we involve more LEDs. So for instance, in this, let's just look at y. We are using variables 4 and 0. So we have LED 0 and LED 4 up here, and that's for y. And so if the y-axis moves up, we will see this LED blink, and if it moves down, we'll see LED 0 blink. And we have to turn the LED that isn't supposed to be running off. So if we detect a positive change in y where we lift it up, that we should see LED 4 turn on and LED 0 should be turned off. And so that's what this logic is handling. All right, I think that's it for the code. I will do a brief demo of all. All right, and this is the simple accelerometer. We have X changes being reflected in LED 0, it'll glow red. Z changes are reflected in LED 1, they're blue. And Y changes are reflected in LED 2, and those are green. All right, so let's just do the Y. We'll see the Y changes occurring. We can do Z, or X, excuse me. And then we can do Z. Well, you can see them all blinking there. All right, that's it. All right, this is the improved accelerometer. We will see positive and negative X detection on these 2 LEDs here. If we're to move left and right, it will correspond to that direction. Similarly with Z, we will see, if I'm not mistaken, these are the Z LEDs, LED 9 and LED 5. And then Y is these 2 here, LED 4 and LED 0. And we'll see green and blue and then red corresponding to the movement of the board itself. So if we were to move it in the X direction, we will start seeing red, and then in the Y direction, which I was wrong, it's this side, we'll start seeing green. And then in the Z direction, we'll start seeing blue LEDs. All right, that's it. All right, and this is the Cycle LEDs project. All we have to do is press this button here, and then the lights will start to circle around the board. All right, and that's it. All right, here is the simple LED and buttons. This is using Arduino IDE and using their variety of C++. So if we press one of the buttons, the LEDs on that side will turn on. There are all the blue LEDs and there are all the red LEDs.